your marine sextant. Okay, we will be using this instrument for taking the horizontal sextant angles between the terrestrial objects and a vertical sextant angle also from the heighted objects such as your lighthouse or anything. Okay, and it will be used for taking your celestial observations. Okay, so now it is a precision instrument. Okay, but still it is having some errors in it, so we need to correct those errors, and first we need to identify those errors कि वो errors हैं कौन से. Okay, so first of all, the way to hold a sextant is take your left hand and hold the plane of the sextant with it. Take it out from the box, and this is the cradle. Use your right hand to hold the cradle. This will be called as the locking device in the sextant. Make sure that it is at 0. Okay, this is the micrometer drum. Okay, this will be the eyepiece and this will be the telescope. These are your horizon glass shades, and these are your index mirror shades. Okay, this is the horizon glass, this is the index mirror. Okay, this is the adjustment screw for your index mirror, and this will be the adjustment screws for your horizon glass. Okay, this is the graduated arc. Okay, and this will be the plane of the sextant. This is your pivot point, this point where the pivot is there, the index arm is there, so that will be your pivot point, and this will be your index arm. Okay, so now when you are using the sextant, make sure you don't move this index arm. You just clip on this locking device so that it is free to rotate, and then you will be using your hand, the right hand, to move the sextant. So actually you are moving the cradle, not the index arm. Okay, so your cradle is supposed to move, not your index arm. It should stay stationary. Okay, and then you should move your right hand and move the cradle with that. Okay, so now talking about the errors in the sextant. So firstly we got perpendicularity error. Okay, so for perpendicularity error, the index mirror is not perpendicular to the plane of the sextant. Okay, so now how will you identify this error? Set the index arm to an angle of 40-50 degrees, whatever you wish. So, and then you look in the index mirror. You look the reflection for this graduated arc. Okay, and then you look at the graduated arc, the actual graduated arc. So the reflection and the real graduated arc should lie in a same line. Okay, if it is not in the same line, you have some perpendicularity error in it. Okay, so you need to correct that error by adjusting the screws behind the index mirror. Okay, now you want to correct for your side error. So how will you identify the side error? So take any object, okay, and see through the eyepiece. That object, the true image and the reflected image on your horizon glass, okay, should superimpose vertically. Okay, vertically they should superimpose. So if it is not superimposing, then you have the side error. So you will use your two adjustment screws behind your horizon glass to correct the side error.
Superimpose means that they would have to be come in straight line.
Straight line.
And it should be taken always vertically.
Yes, always vertically. Then only you will get the side error. So by side error you mean that horizon glass is not perpendicular to the plane of the sextant. Okay. Because for index mirror you can see it like this horizontally, you can see. But with the horizon glass, you need a vertical separation, you know. Okay. So there has to be the vertical separation between the true image and the reflected image. So they should be in a line. Okay. And they should superimpose each other. So you won't be having any side error then. And if you have, you do the adjustment with the two screws behind the horizon glass. Okay. Okay, next in line is your collimation error. But actually this error you cannot correct it on board. You need a instrument called collimator, okay, to adjust this error. So you will send it ashore and you will get it corrected over there. So basically what this error is, that the line of sight that is coming through the telescope is not parallel to the plane of the sextant. Okay, so if it is not parallel, you will be having some collimation error that will be adjusted by the collimator. The instrument is called collimator, and you will send it ashore. You cannot do it on board because it is not practicable to correct this error on board. Okay, next in line comes your index error. So this error will be when your index mirror and horizon glass is not parallel to each other when your index arm is set at 0. So this is the core element in this, that it should be set at 0, your index arm. Then only you can identify for this error whether it is there or not. Your horizon glass and your index mirror are parallel to each other or not. Okay, so you will set your index arm to 0 and then you will see that whether the error is there or not. And if the error is there, then you will use the micrometer drum. You cannot adjust this error. You can only apply this error. So you will adjust your micrometer drum. So now supposedly you are seeing the horizon. So your horizon, the true image is down below and the reflected image is little bit slightly up or slightly down. So if it is slightly up or down, you will use your micrometer drum and you will keep on rotating it until unless your horizon is in a line. Okay, so when it comes in a line, that much will be your index error. And now index error will be if it is from 0 to 120 on the graduated arc, it will be on the arc. Okay, so you will minus this error. Okay, and now if it is behind 0, so that will be off the arc, you will add that error. Okay, so basically off the arc is meaning that your 0 is somewhere behind. Okay, your actually the 0 mark is somewhere behind. Okay, and on the arc will be meaning that you're actually the 0 position. Actually when the horizon glass and index mirror are parallel to each other, that is lying somewhere ahead of your 0 point. Okay, so you will minus that error. Okay, now we are talking about the non-adjustable errors. So non-adjustable errors are, first of all you got the centering error. Okay, so centering error, basically what this sextant is meaning is, it is 1/6 part of the whole circle. Okay, so if I place 6 sextants like this in a circle, they will form actually a circle. Okay, so this pivot point is the center of that circle. Okay, so that is why it is called centering error, because it is the center and it is dealing with this pivot point thing. So now when your pivot point is not at the geometric center of the arc's curvature, okay, you will be having the centering error. So basically what the thing is this, ki this pivot point should lie exactly at the center of that geometric circle. It should lie at the center of that. So if it is at the center of it, there will be no centering error. And these errors you cannot adjust on board. You have to send the sextant ashore to get it corrected. Okay. Now next in line comes your shade errors and like optical errors, what we call. So shade error and prismatic errors. Okay, prismatic errors will be dealing up with your when your index mirror, this index shades and your horizon glass shades are not parallel to each other. You will be having some prismatic error. And shade error will be that the horizon glasses itself are lacking parallelism. Okay, the horizon glasses are lacking the parallelism, so that will be the shade error. Yeah. So now the next one is your worm and rack errors. So now as you can see is this graduated arc. Can you see?
Yes.
There are teeths over there. So by the constant use of this sextant, this teeths will wear off. They will give away. Okay. So when they have given away, there will be some worm and rack errors inside this instrument. So that is also you cannot correct it on board. You need to send it ashore for the proper grinding of the instrument and all. That is a very fine instrument, so they will do it. Okay, so these are the Walkman trackers. Okay, now what the surveyor is interested in, he will be giving you reading, and the reading will be somewhere like this. Okay, so now can you read the reading for me?
First we have to read this one, right? 20.
No.
Then
What the thing is this? Okay, now you will make